Hello class. This week we will be learning about one very interesting topic, machine learning. In the last 3 weeks, we were learning about artificial intelligence and its influences on different aspects of society. However, artificial intelligence is also an umbrella term under which we can find a term called machine learning. Machine learning can be done through the set of techniques that will create mathematical algorithms from the collected data, and by doing so, enables computers to make intelligent decisions. For example, if we have a function f, then machine learning algorithms can be described as teaching and learning a function f to best map input variable x to an output of variable y. So for example, y equals f of x. Learning is the ability of an agent to improve its behavior based on experience. Based off of our learning definition, we could conclude the following. The range of behaviors is expanded, or the agent can do more. The accuracy on the tasks is improved, so the agent can do things better, or the speed is improved. The agent can do things faster. Just like when you were learning to type, you may have started with your home row of keys and practiced one key at a time, and then two, and then you've branched out into other rows of the computer, into numbers, into shifts using the function key, and you were getting faster and more accurate as you learned. That's exactly how computers learn as well. The main task of supervised learning is that for the given set of training examples made up of input-output pairs, it predicts the output of a new input. Learning may be based on the following 4 approaches. First, choosing a single hypothesis that fits the training examples well. Second, predicting directly from the training examples. Third, selecting the subset of a hypothesis space consistent with the training examples. And finally, fourth, finding the posterior probability distribution of hypotheses conditioned on the training examples. To describe the supervised learning, we can start from the assumption that the learner is given the following data. The set of input features x1, x2, all the way to xn. The set of target features, y1, y2, all the way to yk. Set of training examples, or where the values for the input features and the target features are given for each example. A set of test examples are where only the values for the input features are given. The goal is to predict the values of the target features for the test examples and as yet unseen examples. At the following figure, we can see a typical example of a classification task. The goal is to predict whether a person reads an article posted to a bulletin board given properties of the article. So here goes figure 7.1. Input features are the author, the thread, the length, and where it was read. The target feature is the user action. We have 18 different training examples, each of which has a value for all of the features. Algorithms that simplify the function to a known form are parametric machine learning algorithms. The algorithms involve 2 steps. Select a form for the function, learn the coefficients for the function from the training data. Some examples of parametric machine learning algorithms are linear regression and logistic regression. Algorithms that do not make strong assumptions about the form of the mapping function are called non-parametric machine learning algorithms. By not making assumptions, they are free to learn any functional form from the training data. Non-parametric methods are often more flexible, achieve better accuracy, but they also require a lot more data and training time. Examples of non-parametric algorithms are support vector machines, neural networks, and decision trees. For more information, read your book excerpt for this week, which is Artificial Intelligence, The Foundations of Computational Agents, Chapter 7 and Chapter 11. The website for this information is found at http://artint.info/artint_169.html. You can also find a link to this reading in your reading section for week 4. Have a great week, and I'll see you in week 5.